All right, so are you ready to dive into a real cosmic head scratcher? We're talking about a signal, a powerful burst of energy coming from a place that should be basically silent, a dead galaxy.
You know, it really is a game changer. I mean, what's so wild is that it challenges everything we thought we knew about these things called fast radio bursts.
Fast radio
Yeah,
bursts.
FRBs for short.
Okay, so FRBs.
And we thought they came from, young, energetic stars. But this signal coming from a galaxy that's not making stars anymore just doesn't fit.
Okay, so for those of us who haven't been, brushing up on our astrophysics lately, break it down for us. What are these FRBs and why are astronomers so obsessed with them?
Well, just imagine like a sudden flash of energy, but instead of light, it's radio waves.
Okay.
Super intense and super short. We're talking milliseconds. But in that tiny bit of time, they pack the same energy as our sun puts out in an entire day. And get this, they're coming from galaxies millions, even billions of light years away.
Okay, wait, that's insane. We're talking signals traveling across the universe basically from the dawn of time. But why all the fuss about this one coming from a dead galaxy?
Because it throws our prime suspect out the window. We thought young active stars were making these FRBs, the kind you find in galaxies that are busy making new stars. But this new discovery, FRB 2240209A, it blows that theory out of the water.
So it's like you're at a crime scene, right? And you find a smoking gun, but the main suspect has a perfect alibi.
Exactly.
So where do you even begin to look next?
Well, it means going back to the drawing board, right? Astronomers are having to rethink their models, all their assumptions, basically starting from scratch to figure out what else could be causing these powerful bursts.
I bet that's more than just an academic exercise. Finding an FRB in such a weird place has to have some pretty big implications, right?
Oh, absolutely. This isn't just a weird one-off. This is potentially changing how we understand FRBs completely. It suggests they could be way more common and much weirder than we ever imagined.
So it's not just about this one weird signal. It's about potentially rewriting the book on these cosmic bursts. Tell me, how did they even find this thing? I mean, we're talking about a blink-and-you-miss-it signal from a dead galaxy. How do you even start looking for that?
Well, that's where the CHIME telescope comes in. This thing is amazing. Basically a giant ear listening for the faintest whispers of radio waves from across the universe.
Cool.
And they just added these things called outriggers to the telescope. They're like smaller telescopes that work together to act like a magnifying glass, so astronomers can zero in on where these bursts are coming from.
Oh, that's awesome. So, like, they've got a cosmic detective on the case, zeroing in on the signal's location. That's how they figured out it was coming from a dead galaxy, right?
Bingo. And that's where things get really interesting, because if it's not young stars, what is it? The best guess right now is something called a globular cluster.
Globular cluster. Remind me what that is again?
Imagine like a super crowded neighborhood packed with ancient stars. Some of the oldest in the universe, they kind of hang out outside the main part of a galaxy, like suburbs of the Milky Way, and they can have millions of these old burned out stars.
Okay, so we're talking about a cosmic retirement community. Not exactly the kind of place you'd expect to find these crazy, energetic FRBs coming from. This is getting weirder by the minute.
Oh, and there's more. If this theory pans out, it would be only the second time an FRB has been linked to a globular cluster. And the other one, that was found in a totally normal active galaxy, not a dead one. So even this possible explanation just leads to more questions.
So let me get this straight. We've got this FRB, a signal from a place that shouldn't even be making them a possible connection to these ancient star clusters, and a whole lot of scientists scratching their heads. What happens now? Where do they go from here?
Well, I think the first thing is they're going to keep listening, keep gathering data on this FRB and any others they can find, especially the ones in these weird, unexpected places. The more they find, the more pieces of the puzzle they have.
So it's a numbers game now. Just collect enough data, and eventually the mystery of these FRBs will solve itself.
Kinda, yeah. The more they find, the better, and that's where those CHIME outriggers are going to be so important. Remember we talked about those?
Yeah, the cosmic magnifying glass.
Right. Being able to pinpoint the locations of these FRBs means they can really study those galaxies, look for clues, patterns, anything that might help explain what's going on.
It's like zooming in on a blurry picture, right? Trying to get a clearer image. So all this is amazing, but it makes me wonder, what's the point? I mean, it's cool and all, but what's the practical significance of studying these little blips from galaxies far, far away?
Oh, it's about way more than just the FRBs themselves. It's about what they can tell us about the space between galaxies, that vast emptiness, the intergalactic medium.
Wait, hold up. You're saying these tiny little bursts can give us insights into those giant cosmic voids. How does that even work?
Okay, so picture this. These FRBs are traveling across the universe, right? And along the way, they pass through this intergalactic medium. It's like a thin soup of gas and dust that fills the space between galaxies.
Okay, I'm following.
And as these FRBs pass through, they interact with it. They leave these tiny little fingerprints on the signal.
So it's like they're carrying a message from across the universe encoded in the signal itself.
You got it. And by studying those tiny changes, those distortions in the signal, astronomers can learn about that intergalactic media. They can figure out what it's made of, how dense it is, even what kind of magnetic fields are out there. It's like using these FRBs as probes, exploring parts of the universe that are basically invisible to us.
That's mind-blowing. So we're talking about using these fleeting signals to map out the invisible universe. The stuff between the galaxies, I never would have thought that stuff even mattered that much.
Oh, it matters a lot. Believe me, that intergalactic medium, it plays a huge role in how galaxies evolve, how stars form the whole grand cosmic story.
Okay, so now I'm seeing why astronomers are so excited about this. It's not just one weird signal, it's a whole new way of looking at the universe. But let's go back to this globular cluster idea for a sec. You said it's only the second time an FRB has been linked to one, and the other one was in a normal active galaxy, not a dead one. What's the big deal about that difference?
That's the million-dollar question right there. It's what makes this discovery so baffling. If these globular clusters are really capable of making FRBs, why are we only seeing them in these very specific situations? Why this dead galaxy? Why not others?
Yeah, it's like there's some secret ingredient, some specific conditions that have to be just right for a globular cluster to make one of these bursts.
You're exactly right. And that's what astronomers are trying to figure out now. They're digging through all the data, comparing this FRB to others, trying to find any clues that might explain why this particular globular cluster in this particular galaxy is acting so strangely.
Sounds like they're trying to solve a cosmic riddle one that could unlock a whole new understanding with how these FRBs are made.
That's a great way to put it. And the answer to this riddle, it could change how we think about globular clusters, about how galaxies evolve, even about the fundamental laws of physics.
Wow, that's a lot riding on one little signal.
You said it. But that's how it often goes in astronomy. Sometimes the smallest discoveries lead to the biggest breakthroughs.
I'm sensing a theme here: unexpected signals, unexpected locations, unexpected explanations. It's like the universe just loves to keep us guessing.
It sure does. And that's what keeps it so fascinating. We're always learning, always revising our understanding of how things work.
So where do we go from here? What are the next steps in this cosmic investigation? Before we get too deep into the nitty-gritty, I think we need to step back for a second and look at the bigger picture. I mean, if we can find these FRBs in places they're not supposed to be, like dead galaxies, what other crazy stuff is the universe hiding from us?
That's the question that keeps me up at night. It's really the core of why we do what we do. The universe is so vast and complex, and we're constantly being shown that we've barely scratched the surface of what's out there.
It's kind of humbling, right? We build these incredible telescopes, we collect tons of data, we come up with these complex theories, and then bam, the universe throws us a curveball like this FRB from a dead galaxy, and suddenly we're back at square one questioning everything.
But that's what science is all about, isn't it? Always discovering, challenging what we think we know, constantly refining our understanding of how things work. And this discovery with FRB 2024-0209A, it's not just about these bursts themselves. It could have huge implications for other parts of astronomy, too.
Like what? Give me an example.
Well, one thing that comes to mind is the search for alien life.
Wait a minute, alien life. How does this FRB connect to that?
It's all about broadening our perspective. If these FRBs can happen in places we thought were impossible, it makes you wonder about where else we might find life out there. Maybe our ideas about what life needs to survive are too narrow.
So you're saying we should rethink the idea that life needs specific kinds of stars or galaxies?
Exactly. This discovery is telling us that the universe is full of surprises. We need to be ready for the possibility that life might exist in ways and places we haven't even imagined. It opens up so many more possibilities for the search.
Wow, that's incredible. And it makes you wonder what other assumptions we're making that might be holding us back from finding life beyond Earth.
Definitely food for thought, right? This whole thing is a big reminder that we need to keep questioning, keep exploring, and always be open to the unexpected.
Couldn't have said it better myself. Well, I think we've covered a lot of ground today. We talked about how mind-blowing these FRBs are, what it means to find one in a dead galaxy, and even how this all connects to the search for alien life. That's a lot to process.
It has been a fascinating discussion. It's always so exciting to dive into these cosmic mysteries and to see how they connect to these bigger questions about our place in the universe.
And to everyone listening out there, we hope this deep dive has sparked your curiosity about the universe and all the amazing things it holds. Keep looking up, keep asking questions, and who knows, maybe you'll be the one to make the next big discovery. Until next time, keep exploring. 6080.